So much, sir. Thank you, ma'am. Thank you, sir, for the invitation. Okay, and best wishes for your this workshop FDP. So, shall I start?
Welcome, sir, and you can start, sir.
Yes, sir, you
Okay,
can start.
thank you, sir.
Okay.
Okay, thank you so much. Okay, good morning, all of the participants. Hope my voice is audible to all of you.
Yes, sir, you are audible,
Good
sir.
morning, sir.
Okay, okay. Fine. Sorry. So actually today talk will be the image caption generation using the deep learning. Here we actually will use the convolutional neural network, zero shot learning. Okay, so these topic we will discuss today. Actually it is the one of the most emerging topic in the computer vision, image caption generation, because in the today's scenario actually they are seeing ki every hand having the a device which is generating thousands of the images. Okay, so we are facing actually lots of the database issue we are facing. So right now actually currently we have millions of the images, but to organize them images, easily organize. If suppose if you want to retrieve any particular images, okay, then first to organize them in a systematic way. Actually, it is, suppose if you will do it in the manually, then it will take the it is a time consuming, then it will take huge time. Also manpower is required. Okay, so that's why we are taking the help of the computer. Okay, because today's scenario there are so many powerful high performance computing system is available, large data set we have. So using both actually we can design a tool or we can design a method which automatically give the caption. So that will be efficient for us for storing the image and also for the retrieval of the image. Okay. So many research scholar who is working in the image caption generation. Okay, and sometimes we are calling the same topic as the annotation of the image, labeling of the image. Okay, so these are the similar area. Okay, so anyone if working, then it will be more beneficial for them also. Here we actually we will go for some advanced topic. Okay, some advanced research what is going on right now currently in this field, that also we will discuss here. So first of all, we will start ki what is the complete module, okay, outline for this image caption generation or labeling of the image. Okay, so first of all, always whenever there we are talking about the image, okay, then first focus will be always on the objects. What is the objects in that image? Okay, because sometimes actually we are capturing the image that is having the only natural scenic image is also there. Sometimes we are taking where lots of the crowd is there, some vehicle movement is there. So many objects are possible. Animal is there, man is there. Okay, nature object is there. So first target always is the objects here. Second, actually we will go for the attributes. Okay, okay. What is the attribute? Okay, so then we will discuss what is the attribute. Attributes means actually we will go for the some characteristics actually we are searching in the objects. Okay, so one by one actually we will go for the term. Okay, these what is the content of the image, then we try to link them. Then third task is the just we will find out the one relation between the objects and attributes. And fourth is the location, means sometimes actually instead of the whole image, actually we are taking only the some portion of the image and we are doing processing on the some particular region of the image, because objects is not lying on all over the image. Okay, it is only in the some particular location. So actually sometimes we are dividing the complete image in the region wise. Okay, and individual region processing we are doing. So this is the about the location. Then at the last, after getting all the four, then we are able to give the proper description of the image. Okay, that is called the caption of the image, or sometimes we are giving the label of the image. So for example, suppose there is the one image having the one cat is there, dog is there, So these are our objects. Okay, then we have to give them some attributes. Attributes means class, we can say. Okay, and some name of the object, similar name of the object we will give, that is called the attributes. Then we are finding some relation there. Then location wise we are doing processing, or at the last, after doing all these four processing, we are able to give the some caption to the image. Okay, so first of all, what is the motivation behind the image caption generation? Because always we are saying ki suppose if they, okay, first of all, whenever we are seeing the picture, okay, then always we are manipulating the some description of the image in our mind. Okay, so that is our motivation. Whenever we are seeing any image, then in the immediately we are making one picture in our mind, and then we are trying to give some description about the image, and that is mostly based on our past experience. Okay, whenever we will see the image, then we will always check that what is the similar things which we have seen earlier. Okay, so based on that we are trying to give some description. And second thing, it is actually the bidirectional process. So the caption generation is the bidirectional process. Means sometimes actually whenever we are seeing image, then surrounding text is okay. Suppose if sometimes it may be possible that we are seeing one image which we have not seen earlier in the life. Okay, so in that scenario, what we are doing, we are just checking what is the surrounding text if there is existing. Otherwise, whatever the previous similar content we have seen. Okay, so that is the bidirectional process one. Okay, so this is the one exam. Okay, one of the paper. Okay, Mind's Eye actually, it is the one of the best conference PR, computer vision and pattern recognition. Okay, they have presented this paper where they have explore about the image caption generation. So for example, this is the one cropped image is there. Okay, actually it is the bigger image, but it is cropped in the one particular object. Okay, and then given one label there, a girl is there. Okay, then same image again we have captured here two objects. Okay, then we have combined the relation, a girl and boy label we are getting here. Third object again in the different image we are getting with the two objects, and third is the door. Okay, so then we are formulating the one caption, a girl and boy is knocked. And saying it is the bi-directional, sometimes it is maybe possible ki always whenever we are checking the image on the web. Okay, then if we are going on the backhand, then there are the some floating text is also there. So what we are doing, we are taking, one is the vision, second is the language. Okay, so vision is the visual content present in the image. Okay, that we are seeing one thing, and second is the we are hello.
नाही मी ठेवलंच आहे ना. पण स्क्रीनशॉट मात्र आठवणीने काढू शकता. काढ. ते काय त्याच्यावर
So one is the vision and second is the language we are taking. Okay, so two things we are taking, and there are the bidirectional relation between the vision and language. Okay, so using these two things, actually we are representing the image, or we are giving the description about the image. So in the vision, actually always we are what we are looking the objects. Object means there are some visual content is there. Okay, in any image. Okay, either it is the medical image also where there are the not object, but still we are looking some visual content is there. Okay, and sometimes, okay, second things we are taking the language. Okay, so we are using both things, and then we are representing the image. Okay, next we are coming is the what is the image annotation, means what is the annotation, okay, which we are giving to the image. Okay, so actually image annotation is the giving some label to the image. Okay, which represent the content, what is the content inside image. Okay, that we are representing using the label. Okay, so again the content of the image can be the two types. Okay, one is the visual content and another is the semantic contents. So in this okay slide you can see there are the four pictures. Okay, so first picture having the some labels. Okay, which is the beach, clouds, light, orange, red, reflection, sea, sky, and sunset. Okay, these are the some possible labels. Okay, associated with the image. Similarly, in the second we can see there are the some labels, which is the landscape, boat, clouds, nature, green, spring, tree, water, and sky. So these are the some label associated with the second image. Similarly, there are the third image is there, okay, which we can say there is the label is a black and white, street, turkey, and city. These are the some label. Fourth is the some garden image capture where black and white. Sorry. So here actually in the first image, if we will see, then beach and clouds is the visual labels. Okay, so means directly it is the visible. So we are telling it visual label. Okay, but suppose if we will take the first label of the reflection in the first image and turkey one label in the third image, then they are the not visual label, they are the semantic labels. Means directly from the visual content we are not able to get these labels. Okay, so then what we are doing, we are searching some text. Okay, so using the text we will give these types of the label. So this is the two types of the label. One is the visual label, second is the semantic. So visual labels are directly derived from the visible content, okay, and semantic labels are derived from the visual contents. Okay, so what is the broad categorization of the analysis we are doing? We are giving the one keyword. Okay, just like you can assume कि suppose if we are writing one paper, okay, then there is the one term keywords. Okay, in each and every research paper we are giving one term keywords. Okay, so keywords is actually what we are doing there. Whatever the complete paper, okay, and what is about that pay, okay, what is the about, okay, research. Okay, suppose if we are writing the CNN, okay, any particular algorithm we are using, then we are giving this keyword as in this, okay, particular in the keyword. Okay, so this is the first what we annotating means, simply we will give the keyword to the image. Second is the we are giving the description. Okay, so in the description actually we can give two types of the information. Okay, third is the concept. Okay, system of the concept means actually only we will classify the image. Okay, ki whether it is belong to this level or this level. So this is the systems of the concept. Okay, so here actually in the right side you can see there are the one image, okay, which have taken from the Flickr. Okay, and having the possible the Hercules Hydra duplicate content and duplicate content penalization. Okay, so next thing is the why image annotation is needed, why we are doing the image annotation. So let us take one example. Suppose if we are going instead of the natural or camera images, if we are talking about the any medical images or medical ground images, okay, anything we can take in the example. Suppose if there are the collection of the 50,000 medical images, okay, and if we want to search any particular images, okay, all the particular images which having the cell, okay, out of the 50,000 medical images, okay, in that case if suppose individually we will check all the 50,000, then it will take the huge time. Okay, so instead of the this thing, actually what we can do, we can go for this image annotation. Okay, actually so here two types of the query we can raise here. First is the visual query, okay, where actually we will give input as, okay, as an image. Okay, then what it will do, it will take the input image. Okay, then it will take the visual content from the image. Okay, means it will extract the feature from the image. Okay, and it will store them in the vector. Okay, similar feature it will search from the data set. Okay, so we are assuming complete 50,000 image already having the label. Okay, so what it will do, it will check the similar images. Okay, then in the result it will show the similar images here. So this is the first thing, which is the using the visual query we can do. Okay, so what it will do, it will take input image, then it will extract the feature. Okay, and using that feature it will search. Okay, during the processing time it will search the similar images which having the same feature. Okay, then these types of, okay, it will give in the results all of the similar images. This is the visual query using. Second is the text query. Okay, so instead of the input image, we one thing more also we can do, we can just write down the one keyword here. Okay, keyword means here it is the label. Okay, So it will check all the 50,000 images, okay, and which one having the label cell, okay, it will give in the results. All the images which having the label cell, it will give in the results, okay. So these are the two things, okay, where we have required the image annotation, okay, because similarly if we will check all the 50,000 images, okay, which having the similar visual content, then it will take the huge times, okay. So here actually we are taking the help of the machine learning algorithm, okay, and deep learning algorithm we are taking here. Okay, as the number, okay, as we can see, there are the number of digital image are growing very faster. Even we can say it is growing the exponentially. Not only in the digital image which we are taking from the camera, okay, same medical domain is also facing the same problem. Every day they are producing the millions of the images in the medical domain also. But actually, if we will see, there are the so many images, but still there is the no, we are not taking advantage or benefits from the these images, because we are not storing these images in the systematic way. Okay, annotation, if we are storing the one, okay, medical images in the annotation way, okay, if we are annotating all the medical images, okay, then one thing we can do is, suppose if one radiograph will take one image, okay, and if he doesn't know about any particular disease, okay, or not able to identify, or not do not having some expertise in this field, okay, then simply he can do, he can give input that image, okay, and he can check whether any similar image, okay, suppose, because similar disease images it will give the as an output, okay. So that is the one advantage in that medical domain also for the image annotation. Okay, second, actually it will also help us in the easy and effective retrieval process, because if we are so arranging them, okay, if we are effective then way, then similarly it will also help us in the retrieval process, okay. So application of the automatic image annotation are the, it is also helpful in the organization of, also it is helpful, okay, and whenever we want to classify them, for example, if we are taking the brain image, okay, then there are the two types of the brain tumor also possible. So suppose if we want to store the particular tumor image, okay, then it is also helpful for. And another way we can say object detection, okay, that is also one of the main application of the image annotation, okay, because object detection is the everywhere we are required, okay, because lots of the today work we are doing in the automation, means suppose if we are taking the okay, automatic car driving also, that is also there are the so many objects on the road, okay, so here it is also helpful. Another is the object recognition. Image and collateral text, okay. So here actually, but what sometimes, okay, there are also some problem, okay, challenges also with the image annotation if we are going for the automatic image annotation. So here actually I will explain you what is the, okay, suppose if you directly we will see the visual, okay, we will go for the visual images, okay. So here actually in the left side we are taking one image, okay, of the Hercules and Lennon Hydra, sorry. So in the right side, actually, if we will look at the, we want the similar images, okay, then there are the two types of the similarities there. One is the semantic similarity, another is the syntactic similarity. So here actually, if you will look, okay, so this is the actually one visual content we are getting from this image, okay, and that's why it is giving in the result, okay. This is the actually here it is taking and it will give the this image, okay. So actually if you will see, okay, this is the wrong, actually wrong output we are getting, okay, almost, okay, they having the similar content, okay, similar, okay, content is there, but still if you will this is the totally different, okay, this image is a totally different from the input image, okay. So first is the correct, but second if you will look, okay, it is the not correct. So this is one of the main challenges is also there. कि sometimes it will wrong interpret the visual content also. Okay, because both image having the similar way, but still they are far different from each other. Okay, next is the how we will perform the annotation to the image. Okay, so there are the two way to perform the annotation. One is the manually and second is the automatic annotation. Okay, in the manual annotation, suppose if I will ask you what is the possible label we can give to this image. Okay, what is the possible label which we can give to this particular image? Okay, anyone can respond here. What is the possible? Okay, suppose if we are going for the manual annotation, then what will be the possible annotation which we can give? Means one label. Suppose airplane is there, sky is there, cloud is there, tree is there. So airplane, tree, clouds, airplane landing. Okay. Apart from these, another also is possible. So many labels are possible in the manual annotation. Okay. So first we okay in the manual. If we are talking about the manual annotation, then first we will discuss what is the problem with the manual annotation. Okay. The first challenge is it is actually very time consuming process. Okay. And it will take lots of the time and manpower is also required to the manual annotation. And second biggest challenge is the subjective in the nature, means it will be vary from person to person. Suppose if I will give the label to particular image, then might be it will be different from the someone another who is giving the label. Okay, so it is the subjective in nature. Then we are coming, the next thing is the automatic annotation. Okay, so actually to avoid these problem, one is the subjective in the nature and second is the time consuming process. Okay, most of the researchers are going on the automatic annotation. Okay, so automatic image annotation is the process of automatically assigning the keyword or semantic concept to the image. Okay, which will help in the more efficient retrieval of the image. Okay, so automatic image annotation actually we are doing with the help of the machine. Okay, here we are giving the image. Okay, then there are the so many processing we are doing on the image. Okay, then it will give at the last some label to the image. Okay, now we will discuss the way there are the some history of the image annotation. So actually I have divided this history in the three era. Okay, so first we will start with the early era. So the image annotation has been started in the early 1990. Okay, so first from 90 to 2000 was the early years for the image annotation, where actually most of the focus has been given only on the handmade feature extraction techniques. Okay, with the help of some basic classifier and some annotation model. Okay, so most focus was in the early era was on the handmade feature extraction. Okay, the main concern of all the methods were to the fill the semantic gap. Okay, so actually in the early era the focus was on the handmade feature extraction and the another term is the semantic gap. Okay, so first okay we will discuss what is the semantic gap. Sorry. So what now we were at the what is the semantic gap? Okay, so semantic gap is the one concern. Suppose if you will look at the image, okay, then always we are able to okay identify the more depth in the image. Okay, means we are okay, we are able to, human brain is actually able to or capable to detect the more visual content as if we will compare with the system. Okay, because same image if we will give to the machine, okay, or then machine is not that much capable as we have compared with the human brain. Okay, so that is called actually semantic gap. Okay, because user always interrupt an image in the high level form. Okay, and while computer always interrupt the same image in the low level. Okay, so there are the huge gap. Okay, that gap is in between the low level and high level interpretation, okay, which is known as the semantic gap. Okay, second is the medieval era. Okay, which we have kept from 2000 to 2008. Okay, so there are most of the research was done to fill that semantic gap problem. Okay, so instead of the handmade feature also they have used sometimes, but mostly they have focused on the machine learning techniques, okay, for the image annotation and retrieval. So if we will look in this time span, okay, then there are the most of the papers, okay, where they have focused on the handmade feature extraction with the help of some machine learning techniques. Okay, they have used. Okay, and the another focus they have given in this time span is the correlation between the visual and textual feature. Okay, so here actually two things we have they have used. Okay, earlier they have used only handmade feature extraction. Here actually they have used the correlation between the visual content and the floating text. Okay, suppose the one image is there, then some floating text is also there, then they have done here the some correlation. Okay, so most of the old methods are based on the content-based image retrieval techniques. Okay, so what is the content-based image retrieval and text-based image retrieval? Okay, so these are the mainly two types of the image retrieval. First is the content-based, second is the text-based image retrieval. Okay, so working principle of the text-based image okay, retrieval technique. Okay, so first diagram is showing actually about the okay text-based image retrieval. Okay, so here actually user will give the one query. Okay, and that query will okay search in the annotated image data set. Okay, so here actually we are assuming all the images having the annotation. Okay, so it will check the keyword airplane. Okay, then it will fetch the similar images in the output. Okay, so here in the output actually it will give the all images which having the labeled airplane. So this is the text-based image retrieval. Second is the content-based image retrieval. Okay. So here actually user always will give the image. Okay. Instead of the text, okay, user will give the query in form of the image. Okay. Then here actually we are applying the some machine learning algorithm. Okay. Then they will do the some pre-processing. Okay. Means they will either divide the image. Okay. And if we are talking about the deep learning, then directly they will take image as an input. Okay, where they will okay fetch the features from the image, they will extract. Okay, then they will using these feature. Okay, they will get the some labeled. Okay, then these labels they will search in the annotated image data set. Okay, and after that they will give the results here. Okay, so this is the difference between the text based image retrieval and the content based image retrieval. Okay, now we will elaborate these two types. Okay, content-based image retrieval requires actually visual feature for the retrieval of the relevant and the similar image. Okay, so here actually it is looking for the visual feature in the image. Okay, while the text-based image retrieval we work on the semantic keyword. Okay, so text-based image retrieval. Okay, text-based image retrieval actually requires the image to be annotated. Okay, with the semantic keyword. Okay, so this is the one requirement here actually the image should having the semantic keywords. Okay, then only we can apply the text based image retrieval. Okay, Okay, next is the problem in the image annotation and retrieval. Okay, so based on the low cost of the both digital camera and hard disk space, okay, billions of the consumer have ability to create and store the digital image. So there are the already billion of the digital images stored on the personal computer and in the commercial data set. Okay, so one problem, how to store the images in a retrieve image. Okay, so suppose if we one problem we are facing is the there are the large number of images, so how we will store them, okay, in the both our personal or in the commercial data set, so they can will be okay beneficially they can be used for the easy retrieval process. Okay, so in general actually most of the time people they are not very okay giving too much time okay in the labeling or organizing of the images. Okay, whenever we are uploading, okay, so whenever we are uploading okay an image, okay, then we are not giving that much focus on the what we are giving the caption to the image. Okay, sometimes we are without caption also we are uploading the image. Okay, so label okay, if we are taking one to example, then here we can see images are often stored with the name that is produced by the digital camera. Okay, so most of the time we are doing only one thing ki whatever the okay camera is giving the name okay or caption, from the same caption okay with the same caption we are storing the images without okay changing the text okay without changing the name of the image. Okay, or sometimes it is might be also possible we are giving some vague name okay which is not actually appropriate for that image. Okay, so that also possible we are giving the some okay unused okay different name which is not actually representing the image. Okay, so actually if we are going in overall, then there is the no standard scheme existing for the filling the images. Okay, so individually actually individual person are giving the different caption to the image, so this is the one problem. Okay, okay, so there are actually annotation. Again, there are the two types. One is the explicit annotation, simply implicit annotation. If we are talking about the web image, okay. If we are talking about on the web, okay, there are the so many images on the web. If we are talking, then we can say there are the two types of the annotation we are mostly getting. One is the explicit annotation. Second is the implicit annotation. So first is the rarely we do explicit annotation to our image. Okay, so for example if someone is creating the album of their wedding, then only they are giving the explicit annotation, but we are getting rarely these types of the annotation. Okay, second is the implicit annotation. So actually here implicit annotation means we are getting image only, but this image also surrounding with the some text. Okay, in the web search actually most of the time when we are searching the image, okay, then at the back end some text is there, but they are not that much appropriate for this image. So classification of the image annotation method. Okay, human actually visual okay first is the one human visual system interpret image incredibly while making the association between the subject and objects present in the image. Okay, second, the human being and effortlessly okay effortlessly describe the objects and their associated attributes present in the image. Okay, so researchers actually mostly they are try to do the okay this thing. Okay, first okay main object is the detecting each object present in the image. Okay, then predict the corresponding text okay tag to describe the image content. So broadly actually we is annotation is the categorized in five way. Okay, first is the user interaction based method. Okay, second is the tag length based. Okay, third is the training set based, fourth is the model based, and the last is the learning based. Okay, so in the user interaction based, okay, there are the three way: fully manually, semi-automatic, or fully automatic. Okay, so here actually user interaction means ki there is a one platform is also existing which is we are calling Amazon. Okay, so there are the they are floating the image okay where and they are asking user to give the annotation. Okay, second is the tag length based image. Okay, here actually we are fixing the length of the tag. Okay, so only single label is there, fixed length is there, means we can say ki only two possibility or three possibility, means two means there are only two labels we can give. Okay, so this is the fixed length annotation, and last is the variable length annotation. Okay, Okay, third approach is the training set based. Okay, here we can use the supervised, semi-supervised, and unsupervised three techniques for the image annotation. And fourth is the model based technique we can use, and last is the learning based. Okay, so learning based is actually there they are using the multi-level learning, multi-instance, multi-level learning, and multi-view learning, and last is the distance metric learning. Okay, so actually this is the broad categorization of the image annotation method. Okay, so if you want to go in the detail, then there are also one paper we have published on the image annotation then and now in the image and vision computing. Okay, we are okay here actually we have did the survey of around 250 papers. Okay, okay, all of the paper based on the image annotation technique. So first we will start with the training set based image annotation. Okay, the training set has a complete label. Okay, first is the suppose the training set is given is the having the complete label. Okay, so this is the actually supervised learning where all the training set having the complete label. This is the supervised learning. Okay, second terms is the where the training set has an incomplete label. Means suppose if we have the 1,000 images, okay, and only 200 or 300 having the label, okay, then it is the semi supervised or weakly supervised, or sometimes also we are calling it active learning. Okay, so the data set here in the actually in the semi supervised. Okay, why we are using the semi supervised, that also we will discuss, because you suppose if data set is very large, okay, in that case actually it is not possible to give the label to all the images. Okay, so here actually what we are doing, we are giving the annotation, okay, label to only few images manually we will label, okay, and remaining all will be the unlabeled images. So this is the semi supervised learning. And third, where the not any single image will be annotation. Okay, only there is the note annotation of the any single images. Okay, it is called the unsupervised learning. So actually there, if there is the no label, then how we will train? Okay, so instead of the labeled, actually we will use the metadata here. Okay, metadata means there are the some floating text is there, okay, along with the image. Okay, so instead of the label we will use the text. So first we will start with the supervised learning. Okay, so here actually there are the one picture. Okay, in okay having okay associated with the predefined label, building, shops, street, and peoples. Okay, these are the some predefined label along with the image. Okay, it is the supervised learning. Okay, so okay, if we will talk about the early era and the middle era, then most of the work was based on the supervised learning. Okay, so for the large scale data set train, okay, if we are taking the supervised learning, then if suppose data set is the large, then training time of the supervised model is a very high. Okay, and the another problem is the suppose once you have trained the model with the data set, okay, after that there is okay the data set becomes the obsolete. Okay, then there will be no more use of the data set. Okay, this is the one problem with the supervised learning. And second is the also it is the time consuming task, okay, to annotate all the label. Okay, so to give the label to all the complete images if the data set is very large. Okay, so then next we are moving is the semi supervised. Okay, so actually instead of the supervised, okay, most of the research are now going on the semi supervised learning to deal with the increasing size of the data set. Okay, so the basic motivation behind the semi supervised learning is the it is okay reduce the size of the label training set. Means the okay less number of the labeled training set is required in the semi supervised learning as compared to supervised learning. So in the semi-supervised learning, okay, training okay, data set contains only a small number of the fully labeled image, okay, and a majority of the images are unlabeled or the noisy labeled. Okay, this is the second problem we are facing in the semi-supervised is the noisy label is also possible. Okay, so what is the noisy label here? Suppose only okay with this image there are the three predefined labeled is there: building, shops, and street. Okay, and one label is the missing, and sometimes also it is possible ki when we are going for the semi super, then wrong label also we can give to the image. So this is the comparison between the supervised and the semi-supervised learning. Okay. So in the supervised learning, okay, all the images having the predefined label. In the semi-supervised, okay, only few labels are existing, okay, and few label we will give after the training. Okay. So here are the two possibilities there. Okay, some labels we can miss. Okay, suppose system is not able to give the appropriate label. Okay, and another term is the key wrong label also. It is possible that we can give the wrong label. So third is the training set based annotation is the unsupervised learning. Okay. So in the unsupervised, actually, if suppose if data set is very large, okay, then it is very beneficial. Or okay, always we will go for the unsupervised learning if data set is very large. Okay. So first advantage of the unsupervised learning is that there is the no annotation or label is required along with the images. Okay. Okay. So this is the one of the strongest point of the unsupervised learning. Okay. So in the unsupervised learning, actually, it will use the metadata to annotate the image. Okay. So how we will get the metadata? Actually, for each image present on the image, okay, there are the one URL, okay, which is surrounding with the some text. Okay. So what we will do, we will actually associate the image and the surrounding text. Okay. So whatever the okay text present along with the image, that is called the actually here metadata. Okay. So this is the one example of the unsupervised learning. Okay. So here actually one image is given and there are the some floating text along with the images. Okay. So suppose if we want to give the possible label using the unsupervised, then what will be the possible label here? Okay, this is the image. Okay, so in the system actually we are getting here actually two things. Okay, one is the image and this is the metadata. Okay, so in the URL there are the two things, one image and another is the metadata. Okay, now if we want to give the some possible label, then what will be the possible label here? So here actually we will use the application of the natural language processing we will use. Okay, so semantic concept we will use here. So here what we can do, first we will use the complete paragraph. Okay, after that we will tokenize this paragraph. Okay, then so many ways also there, we can go for the bigram. Okay, ngram. Okay, bigram. Okay, multiple correlation between the text we will check. Okay, either we can go for directly, if we will say the basic way, then we will first find out the frequency of the all token here. Tokens means here single word is there. Okay, so we will find out the first frequency of all the token. Okay, then the easiest way we will choose the highest frequency, but it might be possible the highest frequency will be the I, he, is, am, or article will be there. Okay, so then we can go for the another way, we will tag. Okay, so some tagging is also there, means part of speech tagging also, and some tagging is we can do with the okay to each and every token. Okay, then suppose whatever okay noun, okay, which noun having the highest frequency, that we can choose as an label. Okay. So after in the processing might be possible, we will get the baby, crawling, house and mama. These are the some possible label we can get in the unsupervised learning. Okay. So first advantage of the unsupervised learning is actually it does not require the manually labeled data. Okay. So this is the one advantage. Okay. And the another advantage, there are the possibility that variable length of the label we can get, means so many labels also we can give to the image. Okay. But what is the challenges with the unsupervised learning? The main challenges with the unsupervised learning is कि suppose it might be possible कि the surrounding text do not contain the appropriate words. Okay. So suppose the surrounding text do not actually representing the content of the image. Okay, or might be possible they are the content of the different image. Okay, so in that condition actually we will get the wrong label here if the surrounding text is not appropriate here. So so this is the challenges with the unsupervised learning. Okay, and the performance of the unsupervised, okay, automatic image annotation is always lower in if we will compare with the supervised technique, because there are the so many labels are there. Okay, so out of these, okay, large number of labels, we have to predict the most appropriate. So sometimes actually, if we are talking in terms of the performance, then unsupervised learning is having the less performance if we will compare with the supervised learning. Okay, so next is the image annotation based on the tag length. Okay, so when we consider the length of the tag for automatic image annotation, then there can be fixed length tag, okay, or variable length tags. Okay, so the fixed length tag, actually we can define, okay, total length here. Suppose if we are telling it is the n number of possible label we can give. Okay, so here actually if we are using the fixed length, then there is the one problem. Okay, so directly we will see here single label annotation, then single only one label we can give here. So in the one label we can either give the airplane, we can give the tree, we can give the cloud. Okay, so only possible one single label we can give here. Okay, in the multi-label annotation, actually one more than one label we can give to the image. Okay, so actually if we will compare all these three techniques of the fixed length, okay, single length and the variable length, then if we are taking, if first we will start with the fixed length. Okay, then only two possible label we can give here. Okay, so what is the disadvantage of the fixed length annotation? Ki few important tags we will miss, okay, during the annotation. Okay, so for example, in the first image we are missing the tag street. Okay, in the second image we are missing the tag is the landing and clouds. Okay, in the third image we are missing the tag is the people, market and shopping. Okay, these are the tags we are missing. So this is the example of the variable length annotation. Okay, where there is the no predefined, okay, length of the annotation we can use as much as possible. Okay, or okay, next technique is the learning based annotation. Okay, so the visual feature are not sufficient to annotate all the objects present in the image. Okay, so it might be possible sometimes visual feature, okay, they are not sufficient to annotate all the objects present in the image. Okay, or some, okay, we can say that they are not representing, okay, entirely image the visual feature. Okay, so what we will do, the learning based model primarily focus on the learn a model from the multiple sources of the training set. Okay, so most of the learning model explore the input feature space and have the capability to deal with the incomplete tag. Okay, so the learning based strategy is actually in the classified in the four way. First is the multi-label learning, multi-instance, multi-label learning, okay, and multi-view learning and the distance metric learning. So these are the four possible way of the learning based approach. Okay, multi-label learning. Okay, in the multi-label learning, okay, the technique we can use is the discriminative model. Okay, NN based model, graph based model, multi-label sparse coding, ranking preserving, low rank factorization, MLDC. Okay, these are the possible way in the multi-label learning. Second is the multi-instance multi-label learning, where we can use the algorithm MI-ML boost. Okay, MI-ML SVM, MI-ML KNN, IM. Okay, MI-ML fast, it is the extension of the MI-ML multi-instance multi-label learning. They are giving the different name. Okay, different approaches are there in the multi-instance multi-label learning. Third is the multi-view learning. Okay, and fourth is the distance metric based learning. So we will start with the multi-instance multi-label learning. Okay, in the multi-instance multi-label learning, okay, the complete image, okay, is the representation of the bag of instances. Okay, and each image contains the multiple labels simultaneously. Okay, so what is the key factor in the multi-instance multi-label learning? Every image having a, okay, first of all, always we will consider one image as an image. Okay, if we are taking complete image, okay, then this the number of bag is the one. Okay, so means complete image will be considered as a bag. Okay, or either we can divide the image. Okay, if we are dividing the image, okay, then every region, okay, every dividation we are getting, okay, that is called the bag. Okay, and further bag also having the multiple instance there. Okay, so here actually what is the main way of the labeling is, suppose one there is the one bag is there, okay, and this bag is divided into the multiple instances. Okay, then we will check ki whether any particular instance in the bag is positive or negative. Okay, so always we will check for the all the instance, and then we will give if instance is positive or negative. So if single instance is positive, okay, if the single instance is positive in the bag, then the complete image will, okay, complete bag will be get the label positive, otherwise it will be negative. So multi-instance multiple learning, okay, is the combination of multi-instance learning MIL and multi-label learning MLL. So it is the combination of these two techniques. So actually, what is the learning strategy of the four types of the learning strategy we will discuss? First is the traditional supervised learning, where actually one bag, okay, having the one instance only. Okay, complete image is the only one instance we are assuming. Okay, so this is the traditional supervised learning. Okay, and then what second is the only there are the possible one label. So single instance and single label. Okay, also we can say single instance and single label. Okay, another is the multi-instance learning. Okay, means bag is divided further into the multiple instance, but only possible one label is there. Okay, means each and, okay, in each and every instance we will check the one particular object. Okay, here in the diagram you can see there are the, okay, one black circle is there. Okay, that is the object. Actually what we are doing in the particular instance, we will check if there this particular object is existing or not. Okay, if this particular object is existing, so here actually we will always look for the objects. Okay, so in each and every instance we will check object is presenting in the instance or not. Okay, if object is present in the instance, okay, then we will give label positive. Okay, otherwise label will be negative. Okay, so for every instance actually we will check there is existing object or not. Okay, so this is the way. Okay, so actually second technique is the multi-instance multi-label learning. Okay, here actually first we will take the image. Okay, then we will, second terms is the bag. Okay, so third again bag will be divided into the multiple instance. Okay, but possible label is the only one here. So for, okay, just okay, we will take one example. Okay, so suppose this is the one image. Okay, so first what we will do that, okay, this image we will consider complete image, okay, as a single bag. Okay, so we are not dividing the image. Okay, then we are telling the image and bag will be equal. Okay, so only one bag will be there. Then next thing we, okay, we will divide the, okay, bag into the multiple instance. Okay, so suppose here actually we are dividing the image into the multiple four instance. Okay, and one particular object is presenting. Okay, so suppose this is the one particular object present in the image. Okay, then what we will do, okay, first we will check in the first instance. Then what we will do, we will give label positive. Okay, similarly we will check the second instance. Okay, then we will check object is presenting in there. Okay, if it is present, then again we will give the instance is positive. Okay, similarly we will go for the third instance. Okay, then again we will check the object is present. Okay, then if it is, it will get the weight positive. Okay, similarly we will check the fourth instance. Okay, if object is presenting, then we will give it label to the positive. Okay, so here actually we are getting the all four positive. Okay, so bag, okay, at the last actually after getting on the all instance label, then we will give the label to the bag. Okay, then label will get the, sorry, bag will get the label positive here. Okay, And suppose same we will take another object. Okay, so object first we are taking the one image. Okay, and one bag is there. Okay, then there are the three instance. Okay, within the bag. Okay, suppose complete image is one bag here. Okay, then there are the three instances there. Okay, then what we are doing ki there are the one object is there. So first we will check whether, okay, in the first instance the object is presenting. Okay, no, then we are giving label to the negative. Okay, then we will check the second instance. If object is present in the second instance, then we are no. If it is not, okay, then we are giving the label no, negative. Okay, similarly we will check the instance. Okay, third, if this particular object is presenting in the third instance. Okay, if it is yes, then we will give to the label positive. Okay, so here actually in the one bag there are the total three instance. Okay, and instance is the negative and one is the positive. Okay, so but actually we have earlier told ki suppose if single instance is the positive, then complete bag will be positive, otherwise complete bag will be negative. So here actually we have this one. Okay, in the second statement, a bag is labeled as positive if any of the instance in the bag is positive, otherwise it will be negative. Okay, so this is the main key concept in the MIML. So, so these are the four strategy. Okay, this is the second is the multiple instance. Okay, learning. Third is the multi-label learning. Okay, here actually the instance is the only one, but multiple label is possible. Okay, multiple label means ki here it is might be possible ki, ki image having the multiple objects is okay, multiple objects in the image. Okay. So here actually in this way, okay, suppose if there are the two objects, one is the this one, okay, and another is the this one. Okay, so actually again if there are the multiple objects is there, then also we might be possible there are the different labels is also there. Okay, so this is the third way, multi-label learning. Okay, where instance is only we are taking one, but label is possible more than one. Okay, and okay, when we will combine the technique B, okay, and technique C, okay, means multiple instance and multiple label. Okay, then we are getting the fourth technique, which is the multi-instance multi-label learning. Okay, so here actually for the one instance there are the possible that multiple label also possible for the one instance. Okay, so this is the multi-instance multi-label learning. Okay, if we will talk, okay, just take this one image. Okay, in this image actually there are the multiple labels is there. Okay, okay, and instance we can take one, or we can take the multiple instance also possible there. Okay, but it is the examples of the, okay, this is the example of the third multi-label learning. Okay, where one image is there, so we can multiple label is there, but instance we can take one, or we can take the multiple instance also. So in the multi-instance multi-label learning, what is the main key factor here? One of the main key factor is the bag generator. Okay, why we are telling bag generator is the main key factor? Because how efficiently actually we will generate the bag. Okay, okay, so complete training will be based on the how efficiently we are generating the bag. Okay, so if we okay, one, okay, actually if we are talking about the ideal, okay, best condition, then we can say ki for each and every object if we are able to generate the one instance, okay, then this is the best way. But in the realistic actually it is not possible for each and every object we are getting the one instance. Okay, we are generating the one instance, it is the not possible here. Okay, so So in an ideal condition, actually the back generator should generate one instance for the each object actually, okay, and which is a very difficult task. Means simply it is telling ki suppose if you are taking one image, okay, then there are the multiple image, okay, so multiple objects is presenting in the image, okay, then if we are able to generate the one instance for each object, then okay, it is the best condition, okay, or it is the ideal condition. But in the natural image, you will see there are the lots of the object, okay, which they are overlapping, okay, and they are not easy to separate. Okay, suppose if object are lying okay in the scattered way, okay, and easy to classified, okay, easy to segment, okay, in that condition it is okay. But if you will take the real image, then this is not a easy way to separate the individual object, okay, easily. So one instance for each object is not a easy task, okay. Second is the if the back generator is very effective, okay, then even a simple learning algorithm, okay, if you will use the simple learning algorithm, then also it will produce the very good result, okay. Otherwise we need the sophisticated learning algorithm to obtain the good result. So the in the MIML, three things we are getting. First is the bag, second is the instance, okay, and another is the key how efficiently we can generate the bag, okay, or is the instance for the image, okay. So it is completely depend on the key how efficiently we are generating the bag here. So if it is whatever algorithm we are using for the bag generator, if it is effective, then simple learning algorithm if we will use in the training, then also it will we will get the significant result, okay. Otherwise we have to go for the sophisticated learning algorithm. So now we will discuss various types of the back generator algorithm, okay. So it is actually mainly divided into the three types. One is the non-segmentation based, okay, another is the segmentation based, and the third is the different other types of the method for the back generator, okay. So first is the non-segmentation based. Here actually we are taking complete image, okay, then we are not doing any segmentation on the image, okay. Without segmentation actually we are generating the bag, okay. Second is the segmentation based, okay, where we are segmenting the image, okay, and after that we are generating the bag here, okay. So in the non segmentation actually there are the till now, okay, existing only three methods. One is the row, second is the single block, okay, third is the single block with neighbor, okay, and second is the segmentation based, okay, where we are using the k-mean segmentation, blob world, wave segmentation, or JSEG bag generator, okay. And other we can use is the LBP and the shift, okay. These are the two techniques. In the other also we can use for the bag generator. So first we will start with the non-segmentation based bag generator. So in the upper actually here we are taking one original image, okay, then we will, okay, discuss how efficiently we are generating, okay, all these three techniques are generating the instance here. So first we are taking one image. This is the original image, okay. First is the row segmentation, okay. Row wise non segmentation means actually here actually there is this is the one technique row. So here we are taking this original image is the 8 into 8, okay. 8 into 8 size is the okay, size is the image size is the 8 into 8, okay. So first what we will do, we will first divide the complete image, okay, in the row wise. We are taking the total number of the 8 instance here, okay. So this is the one instance, okay, this is the another instance, this is the third, fourth, okay, fifth, sixth, 7 and 8, okay. These are the 8 instance. Okay, so first actually what we are doing, okay, this is the, suppose I is the one image. Okay, then bag size is also equal to the image. Okay, so we are assuming ki complete image is the one bag here. Okay, so first task is always we have to divide the image into the bag. Okay, so here for simplicity actually we are taking complete image equal to the bag. Okay, so image and bag, okay, both are the equal. Okay, so bag also having the this size, okay, equal to image. Second task is the bag we will generate, okay, divide again bag into the multiple instance. Okay, so here actually in the first row wise actually we are dividing the bag into the 8 instance. Okay, and we are getting the instance in the row wise. So here again total 8 instance we are getting in the first. Okay, then what will be our next task? First we will check ki whether object, okay, so suppose object is the tiger here, then we will check ki object is presenting in the first. Okay, in the first instance object is presenting no. Okay, then we will give the label negative. Okay, similarly we will check for the second instance. Okay, object is presenting no, then we will give label to the negative. Okay, then third, it might be possible object is presenting or not, because only few part of the object is lying there. Okay, so for example if it is getting, okay, negative, if it is also getting negative, okay, here remaining is getting positive. And this is the negative. Okay, so out of the 8 instance total, okay, 5 is negative and 3 is the positive. Okay, in the complete one bag. Okay, so bag here will get the positive. Okay, if single instance is the positive, then bag will get the label positive here. Means we can say ki object, okay, whatever the object, okay, suppose one object is there only tiger. Okay, then we can say this particular image having the object tiger. Okay, so we will give the tag here tiger to the image. Okay, so this is the first method, is the row row wise bag generator. Okay, so actually here you can look. Okay, simply we have taken one image, then we have divided the image into the multiple instance. Okay, so what is the inside process? Okay, first always we will take the instance. Okay, then on each and every instance we are actually applying the technique of the feature extraction. Okay, so there are the some features. Okay, tiger image feature we will take. Okay, then in each instance actually we will look that this particular feature is existing or not. Okay, if it is existing, then we will give the label to that instance. Okay, second is the single block. Okay, single block bag generator. Here actually instead of the row wise, actually what we are taking the 4 pixel. Okay, so here we are taking the 4 pixel. Okay, then again we will slide it. Okay, so we can start from one particular region. So what we will, okay, single block we will take. Okay, so here as for example there are the 4 pixel. Okay, inside this block actually. So we will take the first 4 pixel. Okay, we will start with the left to right, top to bottom. Okay, scanning of the image we will do. So for in the first process we will take the 4 pixel. Okay, this is the one instance. Okay, then what we will do next, we will take the another, okay, next 4 pixel. Then this is the third instance. Okay, so each instance having the 4 pixel here, means it is, we are calling it the block. Okay, so what we will do, we will take one image. Okay, then we will slide from left to right. Okay, top to bottom we will do the same. Okay, so this is the first instance, this is the second. Okay, this is the third instance, and this is the fourth instance. Okay, so there are the 4 instances. Okay, similarly we will get here again 4. Okay, so total 8. Okay, then again here 4. Okay, here again 4. Okay, so in this way we can go 4 from. Okay, so we will take the one instance, and inside the one instance we are taking the 4 pixel here. So this is the one way. Okay, so again we will do the same process. For first instance we will check there is the object is present or not. Okay, if it is yes, then we will give the weight to the instance. Okay, so here in this way we will get the actually total 16 instance we will get here. Okay, so 4 and outside. Okay, in the second here again 8. Okay, here 12 and here 16. Total 16 instance we will get here. Okay, then we will check all the 16 instance. Okay, then we will give the label to the instance. Okay, if single instance is positive, then we will give the complete bag positive, otherwise it will be negative. So, okay, so this is the single block back generator. Okay, third technique is the single block with neighbor. Actually here, okay, in the first row, okay, row back generator, and second is the single block generator. You can see here there is the no correlation between the two instance. Okay, there is the no correlation between the two instance. Okay, so in the single block with neighbor, actually what we are doing, we are taking the correlation with the neighbor also. Okay, so here it is the neighbor. Okay, this is the neighbor and this is the neighbor. Okay, so left, right, top and bottom. Okay, these four block actually we are taking the correlation here. This is called a single block with neighbor. So what we are doing, we are dividing, okay, the image into the first, we will divide into the instance. Okay, then we are checking the correlation between the instance. So actually this instance, okay, this is the middle, okay, center of the instance. Okay, will always first it will check the correlation there. Okay, and after that it will get the weightage of the positive or negative. Okay, so if we are doing the correlation, then it will be more strong if we compare with the earlier these two method, because here we are doing the correlation. Okay, so these are the three technique existing for the image annotation. Okay, so in the back generator image annotation, there are the existing only three techniques: row, single block, and single block with neighbor. Okay, next is the segmentation based back generator. Okay, so in this way actually we are taking one example. Okay, the original image. Okay, where is the object is the elephant. Okay, then we are doing the various segmentation. Okay, and each segmented region actually we are taking the instance here. Okay, whatever the segmentation region we will get, we will LBP and the shift. Okay, these are the two techniques. Okay, using these two techniques we are generating the bag here. Okay, so this is called the miscellaneous bag generator. Okay, now we will look at the some observation on the various techniques. Okay, so first we will start with the non-segmentation based bag generator always perform the better if we will compare with the segmentation based bag generator. Okay, and single block. Okay, single block with neighbor and the low binary pattern. Okay, achieve the best classification accuracy. Okay, and the performance of the row, single block, and the single block with neighbor are better than the LBP for scenic image. Okay, so it is also depend on the image. Also, it is depend. Okay, if we will do the observation on the all the techniques, okay, then we can say कि for the scenic image row, okay, non-segmentation is actually performing the better for the scenic image. Okay, while if there are the object, okay, if we are talking about the object classification, then LBP is performing the better in compared to the row, not on compared to the SBN. Okay, so these are the some okay performance observation of the back generator on the both object and as well as the scenic image. Okay, so here these are the algorithm. Okay, okay, first we will do the back generator. Okay, and after that actually we will apply the training algorithm. These are the various types of the training algorithm we can apply. Okay, so many training algorithm are existing, we can apply any. Okay, so this is the one observation. Okay, so we can say here if we are talking, okay, row. Okay, first is the segmentation based is the row. Okay, single block and single block with neighbor. Okay, this is the under the non-segmentation. Okay, and this is the miscellaneous. Okay, LBP is the miscellaneous. So actually we are getting the in the object. Okay, suppose image is the object type. Okay, then here we are getting this is the accuracy in the row wise. Okay, and if it is the scenic, okay, then using the MI graph we are getting the this accuracy. Okay, so similarly you can check here what is the best accuracy we have achieved in the all techniques of the back generator and the various technique of the learning. Okay, we have used here. So the conclusion is that the color feature actually are more dominating, okay, in the scenic image. Okay, while texture feature are more dominating in the object recognition. Okay, and single block with neighbor usually produce much more instance, okay, than the single block. Okay, which will be also cost the larger computational. Okay, so okay, if we were taking, okay, single block with neighbor, then computational cost will be more. Okay, and the another term, okay, which will be also affecting the result is the patch size. Okay, patch size means the block size. Okay, if we are taking the small block size or if we are taking the large block size. Okay, so if we are taking the small block, okay, so patch size is the small. Okay, then first the overlapping will be more. Okay, if patch size will be, okay, small, then overlapping will be more. Okay, and the second thing also we will face problem is the blind zone. Okay, so what is the blind zone actually? Okay, okay, single block with neighbor, if we are talking, okay, then here actually all the corner. Okay, because there is the no neighbor block. Okay, so all the corner actually they are the blind zone here. Okay, because it might be possible that sometimes, okay, suppose if you will take the image, okay, this is the image and object is lying. Okay, suppose one ground image is there. Okay, and bat and ball are the two objects. Okay, and they are lying in the only in the corner. If you are taking the corner image, okay, then this might be possible you are not able to detect them. Okay, because in the single block with neighbor, because they are lying in the blind zone. So okay, first problem actually we are getting is like is in the single blockage. Okay, out of the three techniques, one is the row, second is the single block, okay, third is the single block with neighbor. So we are getting better performance for the single block with neighbor, but here again having the two problem. One is the it is having the large computational cost. Okay, and second is the patch size. Okay, it is related with the patch size. If it is small, okay, then blind zone will be more. Okay, and when the patch size is the large, okay, in that case, okay, actually the object located in the corner of the image will be not detect. Okay, so this is the second problem with the single block with the neighbor. So actually, to improve the accuracy of the single block with neighbor, actually we have proposed the one, okay, two different approach of the back generator we have proposed here. Okay, in the multi-instance, multi-label learning. Okay, so in this paper, actually, you can also get the detail of the these two techniques. Okay, which we have given the name. Okay, so here are the two techniques. Okay, in this diagram, okay, one by one we will explain. First is the block bag. Okay, so to overcome the limitation of the single block with neighbor, we have proposed the block bag generator. Okay, so here actually what we have done, we have first we have divided an image into the 3 into 3 block. Okay, so first, okay, this is the A is the one blob here. Okay, we are taking the one image. Okay, then first we are taking the size of the 3 into 3 of the each blob. Okay, so second diagram is showing actually the correlation. Actually, we are doing the correlation between the corner. Okay, so second diagram is showing the four correlation. second diagram is showing the 4 correlated corner instance. Okay. Okay. So here M1 is actually we are doing the correlation of the M1 with the M2, M4 and M5 to give the focus on the corner. Okay. That was the one problem we have faced in the single block with neighbor. Okay. Okay, third is actually this is the 4 corner. Okay, and fourth is the 4 non corner. Okay, this is the M4, M4, M2, M6, M8. These are the non corner here. So actually we are doing the correlation of the non corner with, okay, M4 will be with the M5, M1 and the M7. These are the correlation here. Okay, for the non corner. Okay, third is the for the center pixel. Okay, for the center pixel actually we are doing the correlation in, okay, in this way. Okay, so here actually what is the total number of instance we are getting? Okay, first is the 4 is the, okay, total 4 instance we will get here. Okay, total 4 instance we will get here. Okay, and the one instance we will get here. Okay, and again we are doing the both correlation also we are doing the along with the neighbor pixel. Okay, so the first problem was the corner. Okay, so for the corner actually we have solved using the, okay, in the diagram 2 we can see, okay, we have solved the corner problem, okay, in this way. So this is the first method is the block bag generator. Okay, second actually we have given within the name of the spider bag. Okay, so earlier actually we have seen ki all the bag generator, okay, they have okay divided the image into the instance. Okay, instance is only in the horizontal or vertical. Okay, so instead of this horizontal and vertical actually we have focus on the diagonal also here. Okay, so mostly actually mainly it is inspired with the spider net. Okay, so with the spider net actually we have inspired and we have generated bag with the this way. Okay, so first we have taken one image. Okay, so this is we have instead of the block. Okay, we have not taken here any block here. The complete image we have taken. Okay, then complete image is divided into the 16 instance. Okay, so how we have generated the complete 16 instances? Okay, that I will explain here. So first actually we have divided the image into the horizontal and vertical with the center line. Okay, then same we have did in the diagonal also. Okay, so actually we are getting here two region here. One is the outer region, second is the inner region. Okay, two different region we are getting here. First is the outer region. Okay, second is the inner region we are getting. Okay, so how we have did the instance? Okay, so for example in the figure number 2, okay, you can see here ki first, okay, what is the complete steps of the spider bag generator? First we have divided the subdivision in the image by constructing 2 rounds of the net. Okay, so first is the outer round. Okay, second is the inner round. Okay, so 8 correlated instance in the outer block. Okay, and same 8 we have did in the inner block. Okay, so this is the instance first. Okay, you can see this is the instance first, it is located here. Okay, so the correlation we have did here this way, this and this. Okay, so this is the 3 correlation we have did here for the instance 1. Okay, similarly this is the instance 1. Okay, instance 3 for the this. Okay, then instance 4, sorry, 5. Okay, then 7, then instance 9, instance 11, 13 and 15. Okay, so totally we are getting here 8 instance. Okay, same actually we will do in the inner way. In the inner block same we will do. This is the instance number 2. Okay, so outer we have getting the 8 instance, inner also we are getting the 8 instance. Okay, so here we are doing the correlation in this and this. Okay, So these are the three instances. For each and every instance, actually we are checking the three correlation with the neighbor block. Okay. So total actually we are getting here total 16 instance we are getting. So this is the accuracy we are achieving in the block bag and the spider bag or the single block with neighbor. Okay. So this is the result we are getting. Okay. So here actually you can see actually, but the computational time is very high for the spider bag because it will take this in the dividation also it will take the lots of the time, but accuracy we are getting more in the spider bag generator. Okay, next is the zero shot learning. Okay, so till now actually we have seen ki all the way of the annotation. Okay, first we will take the one image in the training. Okay, and then only in the testing whatever image we are taking, okay, class of the label, okay, then only in the testing we can give the label, okay, which we have seen in the training only. Okay, suppose it might be possible, okay, in the zero shot learning is telling it about that ki suppose whatever image, okay, in the training we have seen, okay, in the testing if suppose we are not seen that image, okay, then how we will give the label. Okay, this is the one problem we are facing in the image annotation. Suppose 100 zebra images, okay, horse image we are giving in the training, okay, and in the testing if we will give the zebra image, okay, then what will be the label of the image. Okay, because in the training we have not given any image of the zebra, but in the testing we are giving the zebra image. Okay, then how we will give the label to that types of the image. Okay, means for the unseen object, okay, for the unseen object which have not been seen during the training time, so how we will give label to them. So this is the zero shot learning. Okay, so zero shot machine learning is used to construct the recognition model for unseen target classes, okay, that have not labeled for the training. Okay, it utilizes the class attribute, okay, as a side information and transfer information from source class to the labeled samples. Okay, so what the extra thing we are using is the class attribute. Okay, what is the class attribute that I will tell here again. Zero shot learning, okay, framework deal with the problem of unavailability of the image data set. Okay, and what is the primary advantage of the zero shot learning? The zero shot learning method are capable of assigning even those labels that have not been seen during the training phase. Okay, so this is the main advantage of the zero shot learning. Okay, which label we have not seen during the training, still we can give them label. Okay. So what is the complete mechanism of the zero shot learning? Okay, that we will discuss. Okay, let there be a training set. Okay, which having the two parameter. Okay, one is the x, second is the y. Okay, where x is the training image and y is the corresponding class. Okay, so there are the two parameter. One is the x, okay, which is the training image. Okay, second is the corresponding class level. Okay, so on the which ground zero shot learning is it is telling zero shot learning method try to learn a model that is able to classify, okay, where x dash is implies to y dash. Okay, what is the x dash? It is the testing image. Okay, x is the training image, x dash is the testing image. Okay, and y dash is the corresponding class of the x dash. Okay, so two things, okay, we can see here, we can say here ki x dash is the testing image. Okay, y dash is the testing class. Okay, and x is the training image and y is the training class. Okay, so what is the challenging here ki suppose if, okay, we are training on the number of x images. Okay, and if and in the testing we are giving one different image, okay, which we have not seen during the training. Okay, and still we have to give the label to testing class. Okay, and accurate label we have to give. Okay, so from here, okay, from the y dash we will give that label. Okay, so it should be okay. Zero shot learning is actually working on this one. Okay, because the testing and training classes are the mutually exclusive. So this is the basic structure of the zero sort learning. Okay, here actually two things we are giving. First is the one is the image. Okay, second is the attribute along with the image. Okay, and from the image actually we are taking the visual content. Okay, that is called the input embedding. Okay, and here we are extracting the feature from the image. Okay, visual feature we are extracting from the image. Okay, then we are feeding them into the zero sort learning model. Okay, and from the attributes actually we are taking the matrix. Okay, attribute matrix we are designing from the attributes here. Okay, and this is a zero sort model. Okay, so zero sort model actually taking the two things, one is the image. Okay, and second is the attributes. Okay, so two things we are giving to the zero sort learning. Okay, and with the help of image and attributes actually it will give the one label. Okay, to the class. Okay, so from the image actually it is taking the visual feature, and from the attribute actually it is designing the one attribute matrix. Okay, and that matrix it is giving to the zero sort model. So how it will work completely? Okay, one by okay, so let there be a three classes. Okay, so one example we will take. Okay, so it will be more clear how zero sort learning is working to give the class label. Okay, so suppose there are the three classes. One is the otter, second is the polar bear, third is the zebra. So what are the okay? First, what are the common attributes? Okay, that can describe all these classes. Okay, so the common attributes can be the color, habit, and the food. Okay, that we can take in the animal. If we are talking, what is the common attribute? Then we can say color is there, habit is there, food is there. Okay, so these are the three classes, and these are the possible attributes. Okay, black is there, white is there, brown stripes, water, eat fish. Okay, these are the attributes here. So this is the classes. Okay, these are the three classes. Okay, and these are the attributes. Okay, okay. So one things we have to remember in the zero sort learning. Actually, attributes should be same. Okay, always we have to take the same attributes. Okay, then only we are able to define the attribute matrix. Okay, means black, white, brown stripes. Okay, water, eight fish. Okay, so size of attributes should be the same for all classes. Okay, now next task is okay. First, we have taken the three classes. Okay, and after that, attributes we have common attributes. Okay, list of the common attributes we have found out. Okay, next task is to give the value to each attributes. Okay, what is the value means in the two terms. Okay, yes or no, we will give the value. Okay, so otter is black, yes. White is no. Brown is yes. Stripe is no. Water, yes. Okay, eat fish, yes. Okay. Similarly, zebra having the water, no. Eat fish, no. White, yes. Black, yes. Okay, so straps is getting yes only in the zebra. Okay, so these are the some it will design the this attribute matrix. Here you can see this is the one attribute matrix. Okay, that we will get from the attributes and the value. Okay, so this is the complete process. Okay, this is the complete value. Okay, information we will give in the zero sort learning. Okay, so first is the attribute matrix we are giving. Okay, second is the input image we are giving. Okay, in the training. Okay, so second is suppose polar bear is there. Okay, then these are the info. Okay, image we will give in the training. Okay, and along with the image actually we will give the attribute matrix. Okay, and this is the attribute matrix for the zebra, and this is the image. Okay, Okay, so this is the complete structure, complete process how we will do the training. Okay, so in the training image, actually what we will do, we will give the images and the attribute matrix. Okay, and one more thing, attribute matrix we can generate from the, so okay, text. Okay, floating text is there along with the image. Okay, from using these text, actually we can generate the attribute matrix also. Okay, so validation is there, testing is there. Okay, so we will take the image attributes. Okay, then after with getting the attribute, okay, we will design the labeled embedding matrix. Okay, or attribute matrix for the one particular class. So this is the training, this is the testing. Okay, so this is the way of in the zero shot learning. Okay, actually suppose if zebra image we have not seen during the training, okay, then using the attribute matrix, actually we will give the label to this particular class. So what is the some key factor? Okay, salient feature of the zero shot learning is the training class and testing class are the mutually exclusive. Okay, and the attributes of the all classes are same. Okay, the attributes should be the same for all classes. The attributes can be converted to the binary or continuous value. Okay, so we can convert also into the continuous value. Okay, and zero shot learning models need, okay, need to infer a relation between the attributes and the class label. Okay, so we are designing the one relation between the attributes and the class label. Okay, and so this is the complete process under the zero shot learning. Okay, after that we can use any training algorithm. Okay, so here actually we have used the weighted iterative expectation maximization algorithm we have used. Okay, so these are the some parameters what we will take. Okay, input feature we will take. Okay, classes we are giving. Okay, so these are the algorithm. Okay, this is the algorithm we have used for the training optimization. Okay, and this is the complete process how we will do the training. Okay, step 1 to 4, this is the training. Okay, and this is the optimization process. Okay, and this diagram is actually showing the complete overall process for the learning. Okay, so we have actually published this in the, okay, with the name of paper is the zero shot learning with the WEM algorithm. Okay, in the computer vision and image processing conference we have published in. Okay, and for the experimental evaluation, actually we have used the animal. Okay, with attribute to data set. Okay, we have used. Okay, another data set we have used is the cub. Okay, this is also another animal data set which we have used for the evaluation of our result. Okay, so this is the dimension of the data set. Okay, number of attributes in the first is the 85, and in the cub number of attributes is the 300, 120 to 12. Okay, and this is the categorization of the image. Okay, in the terms of the training, validation, and the testing. Okay, so these are the results which we have get. Okay, on the both the data set. Okay, the best performing method where highest accuracy is achieved. Okay, so using the algorithm we have achieved the accuracy 63 here. Okay, and on the cup data set actually we are getting accuracy 50 here. Okay, another one more actually we have approach. Okay, with the same zero shot learning for the image annotation is the, okay, here we have novel concept of the fully connected weighted bipartite graph. Okay, so this paper actually proposed a inductive solution. Okay, for the zero shot learning problem. Okay, in the two way actually we have proposed solution. One is the supervised multi-class classifier. Okay, okay, is the training on the training set, and further, okay, it is asked to classify the testing image. Okay, here actually what is the main objective we have taken ki, suppose if we for the unseen classes actually in the, okay, testing. Okay, in the unseen classes, to for any particular image, actually what we are doing here, we are trying to give the nearest class. Okay, which is the nearest class concept we are taking here ki, if one unseen object we are getting in the testing, then we are finding the which is a similar nearest class. Okay, which we have seen during the training time. Okay, that we will assign in the zero shot learning weighted bipartite graph here. So here one concept actually we are using the mapping function. Okay, which maps the training class to the testing class. Okay, And another term we are using is the correlation between the seen classes and the unseen classes. Means we are doing the weighted bipartite graph of mapping between the seen classes and the unseen classes. Okay, and fully connected bipartite graph we are using for the mapping here. And we have evaluated this on the same earlier two data set, and one another we have taken here is the APY. So in the case of zero sort problem, okay, zero sort model can be classified in one of the two category. One is the supervised model and the another is the semi supervised model. Okay, so here we are using here only. Okay, and the another concept of the using, okay, another concept to use the this one bipartite graph is the human perception to recognize the unseen classes is based on the supervised technique. Supervised technique means always we will look in the earlier past history when we will see the any unseen classes. Okay, so human first try to find the seen class. Okay, always suppose when, okay, for example, we have not seen zebra in our life. Okay, so whenever we will see the first time zebra, then we will check the characteristics. Okay, first we will go for the attributes of the zebra. Okay, then whatever in the past, okay, which we have seen, okay, nearest class we try to match it. Okay, so that is the concept of the zero sort learning with the weighted bipartite graph here we have used. Okay, so directly I will come on the proposed methodology. Okay, so how is the proposed methodology working? Okay, first is these are the some notation we have used. Okay, X is the trainings, okay, set of the training images. Okay, Y is the corresponding classes of the training set X. Okay, X dash is the testing images. Okay, and Y dash is the testing classes. Okay, and Y bar is the union of the training and the testing classes. Okay, and A is the set of vertex, okay, one for each training class label, okay, and B is the set of vertex, one for each testing class label, okay, and Wij is the weight, okay, the weight of a given age from ith vertex in set A to the jth vertex in set B, okay, and M is the total number of attributes for a class, okay, and Lil is the a label embedding matrix or attribute matrix, okay, okay, and there are the two another term is the total number of element in the set A and total number of element in the set B. So training, okay, training of the multi-class classifier is the one term. Okay, we are taking the training images and the training classes. Okay, in the left side, and the right side is showing the mapping function which we are doing between the training classes and the testing classes. Okay, so here actually the, okay, in the mapping function we are using the bipartite graph here. So one testing image we are taking, okay, which is the previously unseen. Okay, for example, this is the one image we are taking here. It is the humpback whale, okay, which is the previously unseen object. Okay, so when we will feed this, okay, then try to match with the nearest seen object. Okay, so these are the some already existing classes is there. Okay, then it will try to match with the nearest seen classes. Okay, so this is the complete, okay, complete framework of the proposed method. Okay, so testing image we will take, okay, which is not seen during the training. Okay, so it will send to the trained classifier. Okay, trained model we will get the testing image. Okay, then try to classify it to the nearest seen classes. Okay, so here actually two things. Okay, first is the previously seen classes. Okay, and testing classes is the previously unseen. Okay, so there are the one-to-one mapping between the training classes and the testing classes. Okay, and from there it will get the which is the nearest class. Okay, then it will give the nearest class label to the unseen image. So this is the complete by, okay, attribute matrix is there. Okay, this is the mapping function, means we will give the weight to the each and every. Okay, there is the mapping and we will give the weight to the, okay, this is the mapping function we, okay, and multi-class classifier as support vector machine we have used here. Okay, and these are the number of images we have taken for the training and the testing purpose. Okay, from the different data set. Okay, these are the results we are getting. Okay, so for the our data set actually we are getting 66. Okay, for the cup we are getting 48, and the APY we are getting the 32. Okay, and for individual class wise, actually for the individual class wise, these are the showing the performance for the individual class wise. Okay, thank you so much. Okay, participants, please you can ask your doubt or query. Okay, first of all, I will look at the chart. Participants, also you can put your query in the chat box. Okay, also you can mail me. Okay, so I have actually text my mail ID also. You can reach on the mail ID also. Hello. Ma'am, your voice is hello. Yes, sir. Yes, sir. Okay, okay, fine. Okay. Okay, sir. Okay, fine. Thank you so much, sir. Thank you. Thank you so much, all of you. Thank you so much, sir. Okay, sir. Okay, thank you so much, sir. Thank you.
so that we will have a photo.